Alright, sorry about that. So, as I was recording, I guess my storage ran out. Because I have a lot of stuff on my phone, so I deleted some stuff. And now I'm uploading the second part of this video. So when the last one ended, I had dilated triangle FEG by a scale factor of 1/2. And then to do it by a scale factor of 2, you just set it up so that you go start at the center. If I want to dilate F, I'm setting it up at F, and then to dilate it by a scale factor of 2, I'd be extending it to the right there. So that'd be 2 times. Do the same thing for CE. That's 1 time, scale factor of times 2. And then from C to G, scale factor of times 1, scale factor of times 2. And then I just connected all those dots. I labeled the scale factor of 2 as double prime, G double prime, E double prime. Then I've labeled it right here as well. All right, so I also want to show you, like if you don't have a printer at home, which I don't, I just printed these before I left school last week. You can also, just use regular paper and draw the stuff yourself. So if I want to draw this triangle, I'm actually going to draw it bigger, just because it'll be way easier to see the different types of dilations we can do. Sorry, as long as you have a straight edge at home, it's really easy to recreate any shape, as I see all of you do in class. Anyways, so we should be good with that. All right, and then I'm going to make the center of dilation C. Let's say it's right about there. Doesn't need to be super accurate. We're not measuring lengths here. We're just practicing the method of dilation. All right, so they ask in this part here, what scale factor would cause some part of triangle E prime, F prime, G prime, the image of the original triangle, to intersect some part of the pre-image triangle EFG. All right, so we know that to get the triangle right back onto itself, if I want to map this triangle onto itself, that would be a scale factor of 1, right? So scale factor of 1 maps triangle onto itself, or it brings it onto itself. However, we can do more than just positive scale factors. So normally, when I draw a line of projection, I start from the center and I go through the point that I'm dilating. For a negative dilation, I'm going to start from the center, making sure that I line up with point E, but now I'm going to go in the opposite direction. All right, and I'm going to do that with every single vertex. So for F, I line it up as if I were going to draw that line of projection, but now I'm going to start at C and go the opposite direction. I'm going to do the same thing with G now. Line it up so that G and C are collinear, then extend that line in the opposite direction. Okay, so now if I want to match up to see exactly how far it is from my center to E, I'm going to put my center on E of my compass, have the pencil touch E, and now I'm going to hop over in the opposite direction, right there. And this would be times -1, right? Scale factor of -1. If I were to extend this one more time up here, that would be a scale factor of -2. And we do the same thing for all my points. Match up C and F, swing it around. All right, and now here, let's call this F prime. I should have called that E prime over here. All right, and this is times -1. Now for G, match up C and G like that, swing it around. Now we get times -1. We'll call that G prime. Connecting all our points. We can see that when we do a negative dilation, we actually get 1, 2, 3, 4, 5, 6 points of intersection. And I'm sure if you wanted, you could try different scale factors, as long as they're negative. Although if you did like a negative of like maybe 0.1, the triangle would probably still be inside here, not intersecting. So you play around with that, see what else works. Okay. All right, last page. What stays the same? Dilate quadrilateral ABCD using center P and your scale factor. All right, let's use a scale factor of 2. Scale factor of 2. All right, so I'm going to start at P. I'm going to go through A. I'm going to go through C. Just creating 4 different lines of projection here. And let's make sure it's obvious. Scale factor of 2. Okay. I'm going to line up my compass now to the center. And point I'm being dilating, that's A. A goes all the way over here. C won't probably go too far. C will go there. Now for B. I needed to extend that line a little bit further for B. All right, and do the same thing now for D. All right, let's label all those points. A prime, C prime, B prime, D prime, and I'm going to connect them the same way. So A and C connect, so that means that C prime and A prime will also connect. C and D connect, so C prime and D prime will connect as well. Let's see if I can do that a little bit better. That looks better. All right, D connects to B, so that means I'll connect D prime and D prime as well. All right, and B connects to A, so B prime and A prime connect. All right, now I've got my new dilated polygon, or quadrilateral they call it. Looks like a parallelogram, but we don't know for sure. All right, so complete the table. Ratio of PA, so that's the measure from P to A, P to A prime, over the length from P to A. All right, so take a second, pause the video, and try and do this on your own. What do you think is going to be true when I divide the value from here to here by this value from here to here? All right, take a guess at that. All right, well, I know that I'm taking PA and I'm copying it here. So I've really got, let's say if we were to call this value X, this would also be X. So altogether, from here to here, I'd have 2X. So if I take 2X and divide that by X, we know from last year in algebra that those X's will cancel out. I'm just going to be left with 2. So for every single one of these, we should get 2. And we've proven that conjecture right there. What do I notice? Well, every ratio equals 2. We've got the proof of that conjecture right there. Okay, complete the table. B prime A prime over BA. All right, well, B prime A prime is from here to here, and BA is from there to there. Well, I'm going to guess that if this is the shape, this polygon's been dilated by a scale factor of 2, I'm going to guess that all of these sides are double the original side. So I will also use 2, 2, and 2 for here. What do you notice? Does the same reasoning you just used also prove this conjecture? Well, to be quite honest, we don't know the length of CA or the length of C prime A prime, so I can't really use that same reasoning, but I can at least try and measure it, just to give myself some peace of mind. All right, so let's see if I line this up. If I go from A to B, That looks to be about 2.8 centimeters. So AB equal 2.8. If I go from A to B prime, I get to 5.6. All right, so A prime, B prime is 5.6. I take 5.6, I divide that by 2.8. Well, what do you know? We get 2. So we can't quite use the same algebra that we used originally to prove it, but I can prove it just by measuring it. All right, great. So what does this mean? What's the whole point of this? Well, if we were to take all of these sides, B prime, A prime, C prime, B prime, D prime, C prime, A prime, D prime, and add them up, that would just be like adding up all the sides of the shape up here, which we refer to as the perimeter. So not only do we dilate the length of each side, perimeter is dilated by the same factor, by the same scale factor you use for dilations.